Okay, hi guys. How are you? How's your weekend? Have you experienced anything interesting? No?
Very good.
Yeah. Don't worry, I bring something interesting for you today. It's called parameter estimation for linear models. The reason why I choose this topic is that I think it's important in almost all of the areas we need to deal with models. There are parameters in there and we need to estimate, and so that's why I come up with this idea. Okay, so the outline of today's presentation is first introduction part, some basic, very important concepts, and the least square method, which is the main standard we are using to parameter estimation. And then I'll talk about linear models, and I'll give you an exercise. Okay, so let's first get into the introduction part. So I mentioned models before. So what are models? It's kind of an equation with x, which is independent variable, for example, time, right? And the eta is some dependent variable, which is dependent on my x, right? So it's a function, and in this function we have some parameters. They are constants. We may or may not know them. We need to estimate them. There may be beta 1, beta 2, until beta p. P is the number of parameters. Okay. So for example, so this linear model, x is independent variable, y is dependent variable, and we have two parameters. Beta 1 is k, beta 2 is b, right? So for this model, downside, the time t is an independent variable, and c, the concentration, is a dependent variable. So how many parameters are in this model? Two, right? So beta 1 would be C0 and beta 2 is K. Good. So that's pretty clear about the model. That I think it's important to clarify between forward problem and inverse problem. So for a forward problem means you've already known the parameters, and I gave you a bunch of x values. I want you to evaluate y values. So for example, this is y is kx plus b. You know the parameters, k is 2, b is minus 1. And I want you to evaluate y at x is 1, 2, 3, 4, 5. So what are they? This is simple, right? What are they? These are the odd numbers. Right, so these are 1, 3, 5, 7, 9. Right? How do you do that? Just the calculation is straightforward. So that's why it is called forward problem. So in contrast, an inverse problem means you don't know the parameters, okay? But I give you a set of data of x and y's. I want you to estimate the best parameters. So in this model, you don't know what is k, what is b, but I give you a set of x and y values. I want you to estimate the beta. So what are they in this situation? X is 1, 2, 3, 4, 5, y is 1, 3, 5, 7, 9. It's clear, right? It's 2 and minus 1 because we've already go through that, right? So this is clear, but what if the y values are this? Then it's not clear enough, right? So the process, directional process is inverse of the previous one. So that's what is called inverse problem. Okay. So now here's a question. How is it possible to get your x value, y values without knowing the parameters in your model? Where do you get the data? Come on guys, you propose your model based on your understanding in your area, and you want to verify your model. What would you do? You do the experiment. Do the experiment to measure your x and y values.